Hi, good day to all. Welcome you all for my video on module 3 of AI NTM as per the VTU syllabus, which is on electrochemical machining and chemical machining. In this module, you are going to learn about the electrochemical machining in detail, about introduction, principle of electrochemical machining, electrochemical machining equipments, elements of electrochemical machining operations, chemistry of a ECM process characteristics like the material removal rate, accuracy and surface finish, process characteristics like current density, process parameters like effect of process parameters like current density, tool feed rate, gap between the tool and the workpiece, velocity of electrolyte flow, type of electrolyte, its concentration, temperature and choice of electrolytes, ECM tooling techniques and examples, tool and insulation materials, applications, ECM, electrochemical grinding, electrochemical honing, advantages and applications of ECG and ECH. Further, the second part of this module uh, covers the chemical machining, elements of the chemical machining process and the basic elements like about the elements of the process like resists or maskants and etchants, type of chemical machining process like chemical blanking process, chemical milling process, process characteristics of chemical machining, material removal rate, accuracy, surface finish, advantages, limitations and applications of chemical machining process. This is the whole syllabus of module 3 as per the VTU syllabus of non-traditional machining process. It is elective for you people. So let us go with, proceed with the electrochemical machining process. Before I go to the electrochemical machining process, let me have a glance on the module 2, which is basically which has basically covered the mechanical based non-traditional machining process like ultrasonic machining, abrasive jet machining and water jet machining. In all these three processes, a mechanical energy, in to be specific, a kinetic energy is being utilized, or kinetic energy is utilized to remove the material from the target surface or from the workpiece material to achieve a desired dimensions or a shape. Yeah, whether in case of ultrasonic machining or abrasive jet machining, the kinetic energy is transferred onto the abrasive particles, or abrasive particles gain the kinetic energy from the one or the other medium, like in case of ultrasonic machining from the abrasive jet, as well as from the energy from the reciprocating ultrasonically reciprocating horn or tool holder. Whereas in case of abrasive jet machining, it is gaining, abrasive particles are gaining the kinetic energy by the conversion of pressure energy into kinetic energy, and then these high velocity abrasive particles hits the target surface, causing the penetration into the abrasive target surface, or these abrasive particles with a very high velocity penetrates into the target surface and removes the material, or just like plowing of soil in a forming line. Similarly, the abrasive particles penetrate into the uh, target surface and plows out the material from the workpiece. Now, or in case of water jet machining, the water jet itself with a very high velocity or with very high kinetic energy causes the cutting of material on the workpiece. So in all in all these three cases, the amount basically a mechanical energy is utilized to remove the material finally to achieve the desired dimensions or a shape. When we proceed for the next conventional non-conventional machining process, where the mechanical energy is totally kept aside, because here when we speak about the ultrasonic machining or a water jet machining or abrasive jet machining, it is using they are utilizing the mechanical energy. Obviously in that case the workpiece material mechanical characteristics plays a very vital role. That is the kind of machinings to be selected, or the process characteristics and the process effect of process parameters. This all depends on the mechanical properties of the workpiece also. Yeah, finally that's why if it is a very high strength, example the ultrasonic machining or abrasive jet machining, they are specifically suited for the um, brittle materials, whereas water jet machining, it is basically suited for the ductiveness. So material characteristics plays a very vital role. Workpiece material characteristics, especially the mechanical properties of the workpiece material, plays a very important role during the selection of the process. Whereas if the amount of kinetic energy is less, then obviously material removal rate will be lesser, or surface and finish will not be so good. So in that case, we have to come forward, so that this mechanical energy, if we are avoiding, obviously the workpiece without affecting the material characteristics or mechanical properties, how we can achieve a better uh, machining performance. For that, the best solution is the other way of using the energies. Like here in case of electrochemical energy machining, the hybrid, like one half of one part of this process uses the electrical energy, the next is about the chemical energy. Example here, in case all of you have studied about the electroplating, might be in your higher secondary level or in your intermediate level, you might have studied about the electroplating. Electroplating is a concept where the ions from the one electrode will dissolve into the electrolyte solution, in which two electrodes are connected. In simple, two electrodes are connected to a power source or a battery source, and both are dipped in electrolyte container or electrolyte solution, so that the metal ions from the one electrode will dissolve into the electrolyte solution and transport to the uh, another electrode, which attracts these metal ions and get deposit over that. So one electrode will get again thinner with the over period of time, whereas the others will getting deposited and increases its thickness. So this is how the metal ion electroplating is being achieved. Here electrons will get this metal ions will get dissolved into the electrolyte solution, and again further reduction of this electrolyte compound will lead to the deposition of those metal ions on the other electrode, and finally the gas is liberated near that electrode. This is how the electroplating is done. Whereas in this case, in case of electromechanical electrochemical machining, instead of getting these metal ions to go on deposit on the other electrode, if we flush away these metal ions from the from this zone, from this enclosed zone where it is expected to plate. Here we can say this is the zone in which these metal ions will transport and then get deposited over the other electrode. If we avoid this zone and with those metal ions and flush away, once it get dissolves into the electrolyte, the same electrolyte, if it is being flushed away from this zone, then obviously instead of getting deposited, these metal ions will get moved out of this zone. However, at the same time, this electrode will get lessen in its thickness, or nothing but the material will be removed on one electrode. So in this case, we can consider this part as a tool and this part as a workpiece in that case. So by this way we can say that the electrochemical machining is a reverse process of electroplating. So in this electrochemical machining, the workpiece forms the anode and properly installed tool forms the cathode. Workpiece is always connected in the electrochemical machining as anode, and the tool is connected as a cathode in the whole electrical circuit. The tool and the workpiece are positioned closer to each other with a conductive electrolyte flowing through a small gap between the workpiece and the tool. The tool and the workpiece both are kept apart at a small distance. This gap is very necessary because when we are connecting the whole circuit with two electrodes and both are dipped in an electrolyte, when we are dipping the two electrodes in electrolyte, the circuit get completed. Okay, these two are two electrodes. One is a workpiece is a anode and the tool is a cathode. When we dip both in a electrolyte, the whole circuit will get completed, and both need to be kept apart. If they get physical contact, obviously the spark will get generated or arcing will get generated, and it will cause damage to the tool and the workpiece as well as to the whole setup. That's why as much as possible it is better to it is necessary to maintain a gap, and it is not as much as possible, it is highly necessary to maintain a small gap between the tool and the workpiece. The chemical properties of the electrolyte are such that the constituents of the workpiece material go into the solution during the electrolysis but do not plate on the tool. Instead of getting plating on the tool, those workpiece material ions will be flushed away from this machining zone, and the shape which is obtained on the workpiece material is exactly similar to the shaped tool. That is nothing but the tool is made of a shape which is the mirror image of the shape which is designed on the workpiece. That is nothing but the required dimensions and the shape on the workpiece. The same image, same mirror image is created on the tool, and the tool is brought near to the workpiece, so that we can obtain a similar shape on the workpiece also during the machining. One important thing here is obtaining the shape of the tool has a better accuracy, and better accuracy of the tool is the same will be the shape of the workpiece. If the lower the accuracy of the tool shape, then lower will be the accuracy of the obtained workpiece. So that's why it is highly necessary during manufacturing of the tool itself here in case of electrochemical machining. uh, Uh, okay, let me continue. Uh, first of all about the initial state of this electrochemical machining. In the initial state or in the first state of this electrochemical machining, we can see here when the tool is progressing, tool is kept at a distance between the workpiece, at a distance of the are kept apart from the workpiece, and both are connected in a high current density electrical circuit. Please note down, it is a high current density electrical circuit. Both are dipped in a electrolyte. The property of the electrolyte is also very important. That is nothing but like the workpiece metal ions, it should be able to get dissolved in the electrolyte. Further, the tool is connected as one of the electrode in this electrical circuit, and then if we check here, the maximum thickness of the tool lies somewhere here, correct? Let me change with this. The tool shape is maximum at this junction, so if we take the cross section of the tool, the maximum thickness lies here. Even that should be much apart from the workpiece in during the initial state of the machining. As the machining progress, the tool has to be proceed forward, or tool should approach towards the workpiece as the machining progress. and the gap, overall gap will be maintained equally, so that the machining can happen and electrolyte is able to flow between the tool and the workpiece. That is a very important parameter which need to be considered. As the machining progress, the tool will move forward towards the workpiece, and finally the similar shape is achieved on the workpiece area or target surface. So these are some of the equipments of electrochemical machining. So let us go with each part. One is the workpiece, which is also one of the electrode in the electrical circuit. Another one is the which, or we can call it as a anode in the electrical circuit, whereas the tool which is connected as a cathode in the tool is connected as a cathode in the this electrical circuit. And the electrolyte, in a reservoir from which the electrolyte is being pumped onto the machining zone. This whole workpiece is fixed on a fixture. The workpiece along with the fixture is placed on a insulating base. The whole setup of workpiece, fixture and the insulating base is kept in a container, and it is a enclosed, further it is in a enclosed chamber. The electrolyte is being pumped onto the machining zone. Before it is sent to the machining zone, it has to be filtered for any presence of foreign particle or any unwanted uh, suspensions which is found in the electrolyte. That has to be filtered out, and then it is sent to the tool with the help of a pressure regulator. For checking the pressure, a pressure gauge is inserted at this junction, or pressure gauge is is kept at this junction. Based on this pressure, a flow meter or regulator is required here to control the flow, or at a constant pressure the electrolyte is being sent to that machining zone. It is generally the electrolyte is sent to the machining zone with the help of a gap which is present in the tool itself directly. Here let me assume that this is a drilling operation, or if it is a milling operation, then obviously the tool will be moving towards the downward manner. So here let us with that assumption, a constant feed with the downward motion or downward direction is being shown here. So the tool is progressing towards the workpiece in a downward direction. So the downward direction tool movement, we can call it as a feed. The movement of the tool is achieved at a constant speed or velocity, so it is a constant feed we are achieving. So when the tool is progressing towards the workpiece, simultaneously the electrolyte is made to flow between the workpiece and the tool. When it is being flushed, when it is being pumped onto the machining zone, the metal ions which is getting removed or separated from the workpiece or dissolved into the electrolyte. The metal ions which is getting separated from the workpiece or anode will get dissolved into the electrolyte, whereas in the electrolyte the solution is these compounds will get further reduction and causes the emission of hydrogen gas near the this tool, and finally the with the further reduced compounds which is taken out, like the precipitation which is going to happen at the later stages. Those with everything, these metal ions and other things, the electrolyte is further flushed away from the machining zone, and the precipitants will get deposited at the just like a small amount of precipitants which we obtain in the other chemical reactions. Similarly here also, due to the chemical reaction, the precipitants are obtained and these precipitates will get settled onto the bottom of this container, and further this electrolyte is made to flow to the electrolyte reservoir. Since these electrolytes are made to flow back to the electrolyte reservoir, now obviously it may be containing some amount of metal ions. That's why the another reason why this filter is required. Generally this electrolyte is being recycled. That is a basic principle of electrochemical machining. Here you can see the workpiece which is connected as anode and tool which is connected as a cathode to a high power density or high current density power supply, which gives a very high electrical energy or high power available at the machining. When the electrolyte is being flushed, when the electrolyte is flushed into the machining zone, these electrolytes, where we can observe the direction of the electrolyte here, the electrolyte is being sent to the or injected into the machining zone, and it will flush away the metal ions which is getting separated from the workpiece or anode, and it will be flushed away. Further it is going to be collected at the base and then finally to the electrolyte reservoir, and then further this electrolyte which is obtained after machining is filtered, and then it is sent to the electrolyte reservoir and then again pumped. Further filtration is done and then pressure regulator is done, and then it is again sent for the next cycle of operation. As the tool is progressing towards the workpiece, due to the gap which exists between tool and the workpiece, the metal ions which get dissolved in the electrolyte, obviously it is going to have the shape which is similar to the shape of the tool. For the whole process or a whole setup is enclosed in a chamber. If there is any decomposition due to the chemical reaction or any other types of gases which are being obtained, that need to be taken out of this machining zone without harming the operator. That is very important. That's why the fume extractor is highly necessary here. Next is about the electrochemical machining. With respect to the two different parts, if I had just explained about the electrochemical machining with either considering the drilling or milling operation, the tool feed direction which is in the downward direction, which we can observe it here. It is maybe in case of a simple drilling or a milling operation, whereas in case of the multiple cross section areas like unsymmetric different cross section areas of machining has to be done, which can be done simultaneously over the workpiece, which can be multiple cross-sectional machining process will be achieved, or which can be achieved on the workpiece. That is the major with and that is on that is multiple cross sections are being achieved simultaneously. That is the major advantage of this electrochemical machining process, or even in general it is about the major advantage of the whole non-traditional machining process, which is not quite good satisfactorily possible on the or easily possible on the conventional machining process. So let us go with the points or about the working principle. A high current low voltage DC power supply is connected here between the tool and the workpiece. So it is a high current density, low voltage. Obviously when we say high current densities, the current energy need to be very high. So around 8000 amps we can say about very high current density or current energy is being utilized here. And next to that is about the voltage. When the current is high, the obviously we can say the voltage is lesser. it is obviously a connected parameters. Is the DC power supply with a very high current and low voltage is connected between the tool and the workpiece, and tool is connected to the negative terminal, that is cathode, and workpiece is connected to the positive terminal, that is anode. So in all the cases the workpiece is always connected as workpiece is connected as a cathode, and workpiece is connected as an anode, and the tool is connected as a cathode, and the electrolyte is pumped at a very high pressure between the small gap of the tool and the workpiece, so that it can flow easily, and further it can flush away the machined chips or a machined material, or even we can say that this electrolyte will flush away the metal ions without getting further decomposition. Whenever the current is passed, the dissolution of the workpiece is occurring continuously. So meanwhile, the flow of electrolyte washes the metal ions away from the workpiece before they have the chance to plate on the tool. That is the major advantage here. Further, the downward movement of the tool causes the workpiece to take some same shape as that of the tool, and it is highly important to maintain a uniform gap, without which a spark or arcing may occur, and this will cause the serious damage to both as well as to the. So let us go about the equipments of this electrochemical machining. First, about the tool materials. Copper and brass, they can be used as a tool material because they are highly conductive materials. Workpiece materials, generally only conducting metals and alloys can be used, because here the metal ions need to conduct the electricity, and then only it is possible to get separated from the workpiece. The metal ions get separated from the workpiece until unless or it can be connected in this electrical circuit, or else it is not possible. Here the metal ions get separated from the workpiece because of the chemical reaction, that is due to the electrolysis. These metal ions will get dissolved into the um, or due to the chemical reaction which will dissolve the metal ions into the electrolyte. That's why and at the same time, due to the another part which has to be connected in the electric circuit, they need to be highly conducting metals and alloys. That's why only conducting metals and alloys can be machined. Further, a high power DC source of sufficient capacity is required to achieve a high current densities at a machining zone, and each need to be maintained between the tool and the workpiece. Further, electrolyte, a liquid that carries the electric current and also acts as to complete the electric circuit between the tool and the workpiece. Generally, electrolyte, it is a very good liquid with a sufficient flowing capacity that carries the electric current, can be used as a electrolyte in case of electrochemical machining. And further, it is highly necessary to conduct the electric current, because it will act as a one of the part to complete the electrical circuit between the tool and the workpiece. Further, material removal is mainly occurring because of the electrolysis, that is the metal ions will get react with the electrolyte and get dissolves the metal ions into the electrolyte. Further, about the elements of ECM operation, there are majorly five important modules of this ECM operations, or five important elements of this electrochemical machining operation. One is the cathode tool, and the second one is anode workpiece. Third one about the next is about the power supply, second important thing. The third important is about electrolyte filtration and delivery system. Fourth important is about tool feed system, and fifth is about the working tank. These are the five important basic elements of electrochemical machining. Regarding this detailed explanation on elements of electrochemical machining is available in my next video, will be made available in my next video. So kindly watch the next video regarding the further details of the elements of ECM operation. I hope you have understood about the basic principle of this electrochemical machining. regarding the further elements of electrochemical machining. I will discuss it in my next video. Thank you for watching my video, watching this video on the module 3 of the non-traditional machining as per VTU syllabus. I have utilized many internet resources as well as textbooks for preparing this teaching material. As a disclaimer, I declare here that there is no any kind of novelty or I don't claim any kind of novelty or originality in preparing this teaching material. I have used many resources and I acknowledge all such resources through this video. And as a token of gratitude, I thank to all such resources and also to you. Okay, bye, have a nice day. We'll meet again on our next video. Thank you.